Hi, everyone. So, let me share my screen and let's get started. I was told that it works better if I start without the screen share live from the very beginning. So I hope you can see my slides. So the topic of this talk is how to build your own cloud-native platform on infrastructure as a service clouds in 2021. And I would also like to say, please, because of lag, etc., please, if you have any questions at all, use the Q&A feature here in the platform. Okay, so you have that probably on your right-hand side. So if you do have questions, please ask them there. Right, so why are we here? Let's start with a single slide summary so you know what you will be listening to. So, infrastructure as a service clouds, as you may be aware, or on-premise. Essentially, when you deploy there as a DevOps engineer, or so you might feel like there are many missing features, and like there are tons of services that you would love to have, but you don't have access to, that you're used to from the cloud, the more fully featured cloud, and it feels very annoying to be just on an infra as a service cloud. So, does Kubernetes itself solve this for you? No, not really, but it offers a very versatile base platform. So it's not a complete solution out of the box, but on top of Kubernetes, we can deploy cloud native services, and that helps us bridge the gap, which gives you a modern cloud-like experience, even though you might be running on a cloud that is not so fully featured. And let's build our own. So let's build our own platform with tons of great features. Okay. So I hope you're interested and that you want to listen to this talk. Let me just say a few words about me and the company that I work for. So my name is Lars Larsson. When you get the PDFs, you can click on any link here. So for instance, my LinkedIn, please connect with me. I'd love to. I've worked in cloud since 2008, both in industry and academia. And now I'm a senior cloud architect at Elasticys. And that's a company that was founded 10 years ago. So we're going to celebrate this fall. And we are cloud native experts. We manage Kubernetes clusters for customers, and we also have a consultancy branch. And we're certified training partners as well in Kubernetes. What we do is that we make compliant Kubernetes, which is a fully open source CNCF certified Kubernetes distribution, which we also offer, of course, as a fully managed service. So, the topic of this talk. So the problem/opportunity that we are addressing here is that for various reasons, companies are moving away from US-based clouds. So GDPR, privacy discussions, for many reasons, companies are now increasingly moving away from US-based clouds back to EU-based ones, or even some have to take their deployments on-premise. Now, I know that that can be scary. I mean, I talk to many customers that find this annoying, to say the least. They don't know what this will mean for them. They are used to the great security features and the infrastructure as code way of thinking that the modern cloud has enabled them to use. But when they come back to Europe, what they see is, oh, I don't have, authentication really built in. Maybe I don't have a very good storage service. Maybe I don't have a database service. Where do I even put my logs? Monitoring. All I get is information about my virtual machine, but I don't care about that. That's not the level that I want to work on. I need actual insight into my platform, etc. So you don't have any container image registry. You don't have services for continuous delivery like you do in, say, Azure or AWS. I mean, crucial services are lacking. And I mean, obviously, that's a gap that I believe that EU-based cloud providers will take care of. I mean, they will close those gaps. I'm sure of it. But if you have to deploy on-premise, and basically all you get is a hypervisor like vSphere or something, and that's it. That means that you now all of a sudden have to give yourself a cloud-like platform to base to build your application upon. So how do you go about doing that? So Kubernetes, it's the darling of the DevOps world, right? But it's not in itself going to solve the entire problem here. So it's a great base layer in a platform that you can build. So I'm sure everybody here is at least somewhat familiar with Kubernetes. And you know then that what Kubernetes by itself addresses is container orchestration. So you have your containerized applications, and Kubernetes figures out how to run it and how to do it in a scalable and auto healing way. So if a server crashes or whatever, it's going to redistribute those containers to other servers in your cluster. All that stuff just works great. And that's what Kubernetes does. And it does so in an infrastructure agnostic way. So essentially, it means it runs anywhere. But that's basically the extent of what Kubernetes will offer. So it has this great API that you can extend as well. And that's, of course, what we can use. Now, Kubernetes can deploy any containerized application as long as you've done the preparatory work of explaining to Kubernetes how to run it. So that's where the rest of the cloud native ecosystem comes in. So using Kubernetes and a whole bunch of other projects, we get this really nice platform. So the goal for today, and that's a quite ambitious goal actually, is that we will use cloud native technology and Kubernetes to address every topic here. So we will address network security, authentication, storage services, database services, log handling and analysis, application-aware detailed monitoring, backups, container image registry, and continuous delivery. So we're going to do all that today. And because I know that we might have a very broad audience here, if you are a tech person and you would love to see how do I actually do this, there is a repo waiting for you at the end of this talk. So there is a code repository that will set up. So if you just set I can't remember how many environment variables, but like half a dozen maybe, it's going to set up this fully featured platform for you by way of scripts. So you will see exactly what they do. No secrets, all open source. Okay. And if you're not a tech person and you don't care that much about code, also great. Then you can just sit back and listen as I talk us through this. So obviously, we need to start with Kubernetes itself. Now, if what we are targeting is an infrastructure as a service cloud or it's on-premise, KubeSpray is the way to install Kubernetes. Essentially, it can install Kubernetes on anything. So if it's Linux-based and you can SSH into it, KubeSpray can pretty much install Kubernetes on it. So on-premise, VMware virtual machines, OpenStack, smallish EU cloud providers, no problem. It just works. And when you do, make sure you select Calico to provide container networking interface support, because that will give you fully featured network policy support. So network policies, if you're not aware, they are essentially firewall rules within Kubernetes. So you can say that, here is my backend service and here's its database. Only the backend service is allowed to connect to the database. Nothing else. No other components. Only the backend service gets to connect to its database. And that's a very good thing to have, both for security's sake, but of course also for just information security so that you know and that you can prove to yourself and to an auditor that you isolate your components in a correct way. As part of installing Kubernetes, we also need to have a way of getting network traffic into the cluster. So we will run applications in the Kubernetes cluster, and the way to get traffic into it is by installing something called an ingress controller for just reasons of it being basically the safe default choice. Let's install the Nginx ingress controller. And as I said, there's code for how to do all this in the repo. So we make it accessible. In the repo, I use a wildcard DNS entry, which means that we can easily route traffic to this Nginx ingress controller. If you don't do that, if you actually want to have not just one wildcard DNS entry, but you'd rather like to have a way of automatically registering DNS names, so new domain names, you can use this software called External DNS. And because it's 2021, you're not going to expose just unencrypted HTTP services to the internet, I'm guessing, right? So, of course, we need to have something that manages certificates for us. So let's also make sure to install Cert Manager and to have automate, and that gives us the combination here, External DNS and Cert Manager gives us automated domain name registration and automatic certificate renewal. So all you have to do when you actually create an ingress object so that the ingress controller will pick it up is essentially to say, well, here's an ingress. It has a host name, and I also want it to have a certificate. Please take care of all that junk for me, and the system will. So the combination of External DNS and Cert Manager will take care of this stuff for you. And I think that is very powerful. And again, make sure to always use network policies as well to secure your application. So after we've done this, we do have Kubernetes and we have network security. So you can follow along up here in the top right part of the slides to see what we're actually working on and what we have already done. Let's talk authentication. So it's very important for security, information security, and of course, auditing purposes that you know who gets to do what in your cluster. Now, Kubernetes itself supports authorization, which is the gets to do what part of that first sentence there. It has role-based access control features, but it needs to have some help understanding who is actually trying to perform an action. And the way that I've done here in this repo is that I've used something called DEX, which is a federated identity provider, and it's going to do just that for us. So what DEX will do is it will integrate with Google accounts, Microsoft Active Directory, random LDAP services, SAML, you name it. And it's going to issue something called an OpenID Connect token, which Kubernetes can use, but as you'll see, other services can use those as well. So we can install that and configure it to work with Google accounts. And the documentation, which is in the repo, also links to a blog post written by some colleagues of mine on how to configure DEX with Google accounts. So there are a few steps there. You need to be admin of a workspace, blah, blah. You'll see. Now, it's really just a matter of once you've set up authentication, now you can start acting as yourself, sort of, not as just this weird cluster admin, anyone who has access to a particular file that Kubernetes gave you when it installed. No, now you actually use your Google accounts as you perform operations against your cluster. Now let's actually add some storage, because we will add database services, log handling, etc. So of course we need a way to store data in our cluster. Now, in in modern and very nice clouds like AWS and Azure and Google, others, you have basically two types of storage. You have block storage and you have object storage. Block storage being essentially virtual hard drives, object storage being essentially a file server that you can upload files to, and it can serve them back. So like Amazon S3, that's an object storage. Block storage services, they are, of course, very nice to have. It's not necessarily something that you have at your very basic infrastructure as a service provider or on premise. So what can we do? Well, one thing we can do is that we can install something called Rook on top of the networked file system called Ceph. And that combination will give us what Kubernetes calls persistent volume support. Technically, Rook can also be an S3 object storage because, I mean, it's just smart about the APIs that it supports. But you can't really run, at least not if you want to store, say, backups. You don't really want to run the same Rook and Ceph service both for your live data and for your backups, because essentially then you don't have backups. I mean, you don't have anything that will help you in case disaster strikes, at least. You will have basically just snapshots of data, but that's not what you are after, I'm guessing. So, database services. Once we have persistent storage, so once we have a way to store data onto virtual hard drives, we of course need a way to also store data in a relational way, like in a SQL server. Now, how many here have databases in their applications? I'm guessing essentially everybody. Who here thinks it's their core business to manage those databases? I'm guessing 0. So managing databases is, of course, necessary, but maybe it's not your strength. Maybe it's not where you want to actually put any thought and effort into. And that is, of course, the reason, I'm guessing at least, why services such as RDS in Amazon are so popular. So if you are like most companies, you'd rather have something else or somebody else managing your database for you. So maybe you use Postgres or maybe you use Vitess because it's MySQL compatible. What Kubernetes has since a couple of years back is something called an operator. And an operator is a piece of software that runs in your Kubernetes cluster, and it uses the nice API abstractions that Kubernetes offers and access to all like the internal information that Kubernetes, the platform, has about the running containers, the running pods in the cluster. And what it can do is it can monitor the health of your an application, and it can do some smart operative tasks. So in the case of a database service, smart operators like the Zalando Postgres operator, it can do replication, it can do clustering, it can do backups, and it can do point-in-time recovery, etc. And all you have to do, once you've installed this operator, once it sits there and it runs continuously in your Kubernetes cluster, all you have to do to actually request a new database is make a simple document, which the operator will pick up. It will be notified by Kubernetes that here's a new one for you. It will read what's in that document, and it will make sure that you get a database that corresponds to the configuration that you've asked for. So that's going to be a so-called custom resource definition object, and that's it. So it's very simple then to just with a single API call, which of course you can also protect if you want to protect against developers just going insane and deploying databases all over the place. You can protect that with role-based access control as well. Just a single API call will give you a very nice database service that can be replicated, and essentially it's as convenient as RDS and similar services from the big US established cloud providers. So that's very nice. Demo repo, of course, shows how to install the Zalando Postgres operator. So that's very nice. Do take a look at it. So log handling then. So applications. So we prepared. So we have a platform that we can authenticate against. We have storage services. We have somewhere to store databases. We're kind of getting ready to run applications. Let's make sure we can also log information from these applications and that we can analyze them. So the way log handling in Kubernetes works is that there is a component called a log forwarder. And it's going to take all the logs from the pods that are running, and it's going to send them to a logging destination. So for instance, as done here in the demo repo, we have the file beat log forwarder send information to Elasticsearch. And that's basically the industry standard logging database. Now, then you also want to analyze those logs. You want to look at them. You want to see what they contain and maybe search for interesting patterns. You use something called Kibana to do that if you store your data, if you store your logs in Elasticsearch. Now, if you would pay for the enterprise license, it would be possible to integrate with DEX that we installed before, the authentication thing, the federated identity provider. Now, because the demo repo is entirely open source, I couldn't include that feature. So that is actually something that will not be exposed over the internet, but as we'll see, some others are. So it's not done in the demo repo for licensing reasons, but you can access Kibana by using your Kubernetes command line interface kube control. So you can access the service anyways through that way. Okay, so we have logs. We also need monitoring. So what's the difference between logs and monitoring? They are both part of observability in a sense. I know that there can be some confusion, which is why I'm bringing up. So logs are textual information that your applications spit out when something happens, whereas monitoring essentially is anything you can put a number to. So how many requests per second are you handling? How many users are logged in right now? How much memory is being consumed, etc. And the way to deal with monitoring data this year, but also the previous couple of years, has been to use something called Prometheus, which is a monitoring system that works by pulling data from various sources. The node itself in the cluster is one such source. Kubernetes API is another, and your application can be also a source. So all you then need to do is to publish interesting numbers for your application in such a way that Prometheus can pick them up, and then tell Prometheus to go collect from there every 10, 15, 30 seconds or so. And then, of course, you also want to visualize using something called Grafana. And that visualizes data from monitoring systems. So it can use Prometheus to display data. And that combination is so common that it's basically a default now. But again, it doesn't actually come by default installed in Kubernetes. But let's install both, and we can integrate that with DEX as well, so that when you log into Grafana, you actually do that via your Google account. And that means that you can also control who gets access to what. Maybe some of your engineers should only be allowed to look at certain dashboards. Maybe some of your engineers should just be able to look. Others should be allowed to perform other features within Grafana, like ask their own queries, for instance. That type of control is possible if you have nice logins like that. So not everybody just uses like the admin account, because that's of course madness. That's not how you're supposed to do it. So let's talk backups. Because if we do have persistent volumes, that means that somehow the data that they store is important. Now, if it's important, it probably deserves backups. There's a project called Velero that handles just that. So it keeps track of all the persistent volumes. Recall, those were the like virtual hard drives essentially that we made sure that Rook and Ceph gave to us. And Velero will just look at them all and it can back them up. So basically, we just need to install Velero and tell where to store the backups. And any S3-like object storage service will do. I haven't done this in the demo repo because, well, that would assume that there is an external S3 service, and I didn't want to do that. Again, you don't really want to store your backups on the same storage service as you have your live data, because what that will basically just give you is a way to jump back in time, but it won't give you actually back up in the sense that you can bring your system back up again if disaster has struck. Let's also talk about container image registries. So if you run Kubernetes, you have containerized applications, and that means that you need to store container images somewhere. Now, there is a project called Harbor that offers a secure registry, so somewhere to store container images, and it can also integrate with vulnerability scanning features. So that means that you can integrate it with a piece of software that keeps up to date with all known vulnerabilities in open source software. And it analyzes the contents of your containers. And it will give you a warning if you have software in your containers with known vulnerabilities in them. And because it's integrated with Harbor, the registry, it can actually be told to forbid starting a container that has, say, critical vulnerabilities, but maybe it should be possible if it's just like a warning. So that's a very good way to keep your system reasonably secure, at least as much as a static analysis of your container images could possibly give you. And the demo repo shows how to set up Harbor and integrate with DEX. And yeah, as you'll notice, I do like this way of centralizing authentication, because it's just nice to know that everything is tied to a user, and that we have just one way of getting those users into our system. And of course, because DEX is integrated with Google accounts in this case, if you have two-factor authentication turned on, that's going to be a requirement from Google that you have authenticated correctly against Google before DEX can actually come back with a thumbs up or get a thumbs up from Google saying, yep, this was actually Lars that tried to log in. So it's a very nice feature. And finally, so if we can push a newly built container to a container registry, that probably means that we want to deploy it. Maybe we want to do so in an automated way. Maybe we want to always deploy anything that comes into a certain branch for staging or for just general testing. Perhaps we even want to have a button that just lets us click and say, promote this to production. And that we want to be able to do that in an automated and safe way. And one way to do so is to use the great piece of software called Argo CD. And as I'm sure you're tired of hearing at this point, of course, we will integrate that with DEX as well, so that DEX can provide the users. So go do great things. If we have all this in place, that means we have network security, authentication via Google accounts or whatever. We have storage, even though the cloud or on-premise environment didn't provide it. We have database services, which makes it trivial to get a new database up and running and to do point-in-time recovery, etc. We have something that will store our logs for us. We have something that will look at detailed monitoring information. We get backups. We get a vulnerability scanning container image registry service, and we can do continuous delivery. So this is a pretty competent platform, and I'm sure you'd agree. And if you don't, then please use the Q&A feature. So in summary, this gives us a fully functional platform, and it's entirely based off of open source. It's fully based on Kubernetes and cloud native tech, and it works no matter where the cloud is located. So is it a tiny regional cloud? Is it somebody's data center and they installed OpenStack or VMware and now they claim it's a cloud? It's fine. Is it not even a cloud? Is it just an on-premise installation? I mean, it can be bare metal servers. It can be like Hyper-V virtual machines. It can be VMware. It doesn't matter. As long as it's Linux, okay, so Ubuntu, Red Hat, preferably, right? If it's Linux and you can SSH into it, you can install Kubernetes onto it. And if you can install Kubernetes, then the rest of the demo repo is also possible to install. And what we've also seen is that we've been able to centralize authentication using this federated identity provider idea for all operator-facing services. So for all the web dashboards and stuff, and of course for Kubernetes itself, using this role-based access control. So we have everything in place to answer the question, who gets to do what? So we have all those systems that we've talked about. They have the concept of users, and they have the concept of who gets to do what. But DEX is the key component here that answers the question, who is the subject that tries to do something. Now, installing all this stuff is trivial. It takes, I mean, if you run through the demo repo that I'm providing you with, it takes, I think it takes like 15 minutes or something to run through KubeSpray. And to be pedagogical, I first install Kubernetes and configure it once. And then when we add DEX to it, it also has to like restart the API server. So it actually runs through, but it kind of just fast forwards because it actually just needs to change one thing. So that takes less time. So in like half an hour, you have everything up and running. But that's just installing it, right? And installing is kind of the easy and fun part. But then you actually, of course, if this is going to be your production environment, of course, you also need to keep this thing up to date. How do you do that? Because now you have all these various components, and you need to keep not just Kubernetes and the operating system of the virtual or whatever machine that you're running Kubernetes, your Kubernetes cluster on. you have to keep all that up to date. You have to keep all the components up to date. It turns into quite a handful. So while it's fun and easy, and everybody here at DevOps Pro Europe probably loves installing this stuff, it's also the matter of operating it. And that's kind of where compliant Kubernetes comes in. So what we did there is that we made a distribution that comes with more than this already included. It's of course set up in a much better way than just, my scripts. But the key thing is that we can offer it as a fully managed service. Now, just brief architectural overview as well. So as you can probably tell from the name, it's geared towards regulated industries. So especially like healthcare, we know is essentially the most highly regulated type of industry that we know. There are also personal data regulations. It all feeds into and modifies essentially controls. So in information security standard language, you have, they will never tell you, you have to use this particular software in this particular configuration, but they will say you need to have policies in place to make sure that you handle information in a secure way. And you should have controls, you should have systems, you should have something that enforces this. So during this presentation, we have made some familiarity with DEX, with Elasticsearch, with Prometheus, with Grafana, Velero, Tri-V being one of those vulnerability scanners that hardware integrates with, our network overlay, the cert manager, Kubernetes. What compliant Kubernetes also adds, besides, of course, the combination of all this made by people that care about this stuff and packaged together as a single unit that has, regular release schedule, is also something called the Open Policy Agent, which is very cool. It catches any API call coming into the Kubernetes API server, and it will look at the contents of that API call to see whether the API call should be allowed or not. So from just a role-based access control point of view, perhaps I am entrusted to modify or to deploy software to production. Okay? So if we just ask, is Lars able to push code changes to production? The answer will be yes. But what if I accidentally try to deploy a testing version of a piece of software to production? That probably breaks our own internal policies, right? So it's very nice to have something like Open Policy Agent sit there and be able to catch errors like that. And what's also included, what is not in the demo repo, is something called Falco, which does intrusion detection. So scanning for known vulnerabilities, that's nice, but Falco can also do intrusion detection to see if an application deviates from its normal behavior, which you can define in rules and say, it's fine for this piece of software to read and write to a certain directory, say a persistent volume, but it's not okay if it starts to read or write from the etc folder, because that's where the password file is. So that could be a way to detect that a hacker is trying to do something with your software that they're not supposed to. So the benefit of using Compliant Kubernetes, which is, of course, itself open source. So go to compliantkubernetes.io and you can download this and you can start using it. There's documentation for how to install on various cloud platforms. The benefit of having this rather than something that you piece together yourself, or if you took my demo repo that I pieced together for you, is that this is a living distribution. It's actually maintained. It's something that, so whenever there's a new release, all these components are tested together, and we can offer it as a managed service. So if you don't particularly enjoy taking care of and managing a Kubernetes cluster, then at least you can do it. You can have other people do it for you. Right. So that's essentially what I wanted to say during this session. Are there any questions here in the audience? Let me go back to that tab and check. No, I don't see any questions posted just yet. That's completely fine. Let's, as a bonus, because I'm sure I have like 5 minutes left of this session, let's see if this worked. Yes, it did. There we go. That's the link to the platform. I don't know, can I even paste links in this chat? I don't even know. I know I can paste it like in a public channel, but oh, I don't know. Anyways, you are probably very used to GitHub, so just go to Larsson/Cloud Native Platform if you want to check this thing out now, even before getting access to the slides. Here I show how to first set up your cluster and then adding all these features on top of it. So it has some prerequisites, of course. We're using a cloud called Exascale just because it was very easy to work with. They have a good Terraform provider. But rather than using their Kubernetes service, which of course exists, we're just using their virtual machines and DNS service. So as I write here, it's therefore almost exactly what you would get if you deployed onto bare metal or bare virtual machines. Or, of course, some cloud provider that lacks all kinds of fancy load balancing or storage services, because we're not even using them. We're just using virtual machines and DNS. So if you install your prerequisites, and then you have to set 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you have to set 8 environment variables, and then you just you just follow along. You just install using the instructions here in the README, and there you have it. Then you have a nice and fully featured platform. But if you don't enjoy maintaining it, do talk to us. Okay, so thank you for joining this session, and have a wonderful time at the DevOps Pro Europe conference. Bye.